Okay, so today we're going to be looking at finding the area of figures in a coordinate plane. So here were my coordinates. I just graphed it out. I just plotted them in, and as you can see, it forms a triangle. And I have the area formula of my triangle up here, and I also have my distance formula. Now here we need to use our distance formula because we need to find the distances. We need to find the lengths of our base and our height. And it's going to be tricky because like this is at a slant. So we can't just simply count the boxes. So right off the bat, I know that this is going to be my base and this is my height. And this one, it looks to be my hypotenuse, my longest side. So if you're kind of wondering how I'm doing all this, I'm actually basing it off of what I know about a regular triangle. We've been looking at them so many times. This slant over here looks like that longest side, and these sides, well, they're touching each other, right? They intersect at this corner right over here, this right corner. So that's why I'm naming this my base and this one my height. They could interchange. I mean, this could be the base too, this could be the height, but just keep in mind, right? Keep in mind that you don't want to include the hypotenuse. You don't want to include the longest side, all right? Now, I need to find the length or the distance, so I'm going to put it into this formula right over here. So I'm going to say finding the distance of B. So with my coordinates, I'm going to use this one as my first coordinate. You can also use this one as well. I'm just starting off here. So that's x1, y1. This is x2, y2. I'm just going to plug them in. I'm just going to start substituting them. So let's see, 3 minus -4 squared plus 3 again minus 5 squared. All right. So now that I have all of this together, I'm just going to simplify whatever's in the parentheses. So 3 minus -4, that's the same as saying 3 plus 4. And you're going to get 7 squared. And now we're doing 3 minus 5. That's going to be -2. I'm just putting the parentheses there just to let me know that that's -2 squared. All right. So now we have something like that, and now we can start simplifying even further by finding what the exponent is here, what this equals to. So keep in mind, when we're doing 7 squared, it's the same as saying 7 times 7, all right? So 7 times 7, that's 49, and -2 squared, that's the same as saying -2 times -2. That's going to be a +4, all right? So now we can go ahead and start adding these two. So 49 plus 4, and remember we want our square root still there, that's going to be 53. So the length of my base, it's going to be square root of 53. Now I know we want everything to be in simplest radical form, but if we look at 53, right, the only factors of 53 is just 1 and 53. There's nothing else. So because it only has a factor of 1 and 53, this is a prime number, and I can't simplify this even further. So I'm going to leave it as is. Right? So we're going to do the same thing when we find our height right over here. So let me just, oops. Let me just get rid of this. Rid of that. Okay, so we want to find the distance, or the length of our height, right? Now I'm going to keep this as my first point, x1, y1, but this time, this will be my new x2, y2. And this is what what I will be plugging in. -4 minus, oh, well, and make sure you're going in order. So x2 would be this one, -5 minus -4 squared plus y squared. So that's going to be y2, -2 minus 5 squared. Okay, so this is how it looks like, and I just want to simplify with whatever is in the parentheses. So -5 minus -4, that's the same as saying -5 plus 4, which is -1 squared, plus -2 minus 5, that's the same as saying -2 plus -5, that is -7 squared. -1 squared, -1 times 1, that's +1. And we have a -7 squared, -7 times -7, which is a 49. And this will become the square root of 50. Now 50, there's a lot of factors that go into 50. So this one I can definitely get into simplest form, simplest radical form. So let's do that. Right? So to get things in simplest radical form, you just want to break down the factors of 50. So 50, let's see, we can have, if our factors are 1 and 50, 5 and 10, and 2 and 25, right? So between these guys, this one has the biggest perfect square, which is 25, and this one has the biggest perfect square, which is 1. That's because they're perfect squares again because they have 2 of the same factors. So this one has 5 times 5 gives you 25. 1 times 1 gives you 1. And between these two, this one is the biggest one. So I can break this up as being the square root of 25 and the square root of 2. Square root of 25 is just 5 square root of 2. So that is the distance of my height. It's going to be 5 square root of 2. Okay? All right, so now that I have everything set up, I can start finding my area. All right, so let me just get rid of this. Okay, and I'm just going to bring this down here. Good. Okay, so here I'm going to do 1/2. My base was square root of 53 times 5 square root of 2. So with this one, it's going to be, approach it as if you are multiplying like terms. So this square root of 53, I'll only multiply that with the square root of 2. And this 1/2, I'll only multiply this with a number that's not in square root, which is 5. So 1/2 of 5 is 2.5. And this one, the square root of 53 times the square root of 2, I'm going to keep my square root, but I'm just multiplying with whatever is in there. So 53 times 2, that's 106. Now, we're going to check if we can get this into simplest radical form. So again, you want to write down the factors of 106, which is 1 and 106, and 2 and 53, the ones that we just used. And you're going to find that these are the only factors I have. And none of these factors, if you see them, if you multiply them, like you find the factors, So the factors of 53 is just 1 and 53. The factors of 106, well, there's a 2 and a 53, which they're not the same factors. So I can't break this down because none of these have perfect squares. So this will be my final answer, 2.5 and the square root of 106 units squared. So that will be it.